I just
we got that one.
my second question is blank. I forgot what you guys.
That's why I ask like 3 times, so I make sure that I got everybody's before I start giving stuff away. Okay, all right, I'll get over that. Section 9.2, if you've tried that yet, it talks about types of errors. What are the 2 possible results? And there are only 2. There's only 2 results from my hypothesis test. What are they? You could either do what with the null?
Equal to?
No, you never support the null.
Reject the null.
You could reject the null.
Support the alternative.
No. Well, I want you to understand, the reason there's only 2, and some of you guys might be like, there are 4 things we right now. Reject the null means support the high. So I don't need to write that. It's sort of like saying, give me a number that's at least 8, and it has to be not less than 8. Oh, you just said the same thing twice. What the hell? So you can either reject the null or fail to reject the null. I like it. So when would this be a mistake? And this is not a mistake that you make because you calculated something wrong. This is a mistake you make because of the inherent possibility of being wrong, which some people hate about statistics, but I love it. It's the most honest math. So if I reject the null, when would I be wrong? If the null was actually true. You guys will understand. Because remember, what's the whole idea? The null thinks it's in here somewhere. So if I get a sample that's out here, is that sample impossible? If that's the real mean? No, it's not impossible, but it's just very unlikely. So there is a chance that I'll make a mistake. I get a sample out there, I think that's not the real mean. Oh shit, it is actually the real mean. Ooh, and of course, we'll never know. In real life, we just have no idea. There's no way to know. So when will I make a mistake? When will this be an error if I reject a true null? Read that the other way. I like it. And this probability, this is called a type 1 error. I actually honestly don't care that you know it's type 1. I always remember that type 1 is the shorter statement. When I make a mistake here, if I fail, this is a type 1. A type 2, if I fail to reject, if I fail to say that the null is wrong when actually the null is wrong. So if I fail to reject a false null, that's a mistake. That's an error. It's not a mistake we made in calculation. It's just inherent in the way things work. So fail to reject a false null. I like it. So see how that's a shorter sentence? Reject a true null. That's type 1. Fail to reject a false null. That's type 2. The probability of this is alpha. And we're not going to get too deep into it, but there's a lot you could do with the probability of this. It's called beta. Beta is not 1 minus alpha, unfortunately, but if you let alpha get small, beta gets big, but not directly. Okay, I like it. All right, so I'll let you guys try some of those out, section 9.2, if you haven't yet. There's been no questions about it yet, so assuming everybody's done it, that makes sense. Yes?
I have a question for 9.5.
Oh, sure, okay.
1 second.
It's not today for the test yet.
Oh yeah, so that's what we're going over today. We haven't talked about hypothesis tests of a percentage yet. We've only focused on the mean. So today we're going to get into the hypothesis test for a percentage. That's why I got this stuff written up here. Yeah. So you can't quite do all in 9.5 yet. Unless you look up the formulas for it, and then you should be able to. I like it. Anything else from homework stuff before we get into this new stuff? So this is stuff from 9.2, this type error. I like it. We're not going to worry much about beta. Beta is actually kind of a big player, but it's not enough room in Stats 1 to talk about it fully. It's related to the power of the test and all this kind of stuff. It's amazing. It's a little bit freaky to try to get a hold of the number that beta is. So that's why we don't really focus too much on it in Stats 1. So what I have this up here, I want to try to develop a hypothesis test for percentages. Now, can somebody remind me, what's the heart of the hypothesis test for a mean? What are the two steps that are at the heart of it, that actually capture the idea? I love when I ask the questions. Here we go. Damn if I know. So what's the whole idea? In fact, I pretty much captured it here. What are these? What are these here? Sure. So this would be sort of like how many tail test? 2 tail test, right? So this would be represented by, well, what do we do when how do I find these? I have to know what alpha is, and then I find the corresponding what? Those are representing what? Z-scores. With me, so maybe negative 2.326 and positive 2.326, right? I like it. I like it. Okay. So I need to know alpha and how many tail tests it is, and then I can find the z-scores. True. But then the next step, so that's step 3, is to set up how far away is far away enough. Step 4 then is how far away do we get? Now for means, we got a beautiful little formula for the z-score. Do I have a corresponding formula for percentages? Do I? Not yet. We're going to make it. I like it. You're like 50-50 chance. Yes. No. All right. Now, the nifty thing is, I said this when we first did this. What is this acting like? What is it in the place of? No. The error is this whole thing. What is that acting like? Standard deviation. Because if you compare it to this guy, I like it. So here's the cool thing. Here's a nice thing. Hypothesis tests for percentages have the same exact 5 steps. 2 of those steps are going to be a little bit different. One step is this one. I can't use that z-score, so that's freaking means. I need a z-score for freaking percentages. Right? So what I do is, what's awesome is, anybody remember what's the symbol I use for the percentage I get from my sample? It's going to be wearing a percentage I get for the sample, p hat. P without a hat is the percentage from my claim, the assumed actual percentage. Just like over here, that would be from the claim that I'm going to assume it really is that, and that's what I find in my sample. Right? So always my sample first minus the middle over the spread. So now the spread is going to be that. But one small change. What was the purpose of this again? I know, look, some of you guys are out there saying, I'd love to say what I really think, but I probably should. But what was the purpose of this? What did this thing do?
Gives you the confidence.
Confidence interval for the true percentage. I like it. So in this case, I didn't know what the hell P was. I only knew P hat. I only had my sample percentage. Are you guys with me?
Yes.
Yes. So that's why I had to use P hat and Q hat, because I don't know what the hell P and Q are. In a hypothesis test, we assume this is real. This is true. So I don't need freaking hats down there. This was actually just because that's the only thing I had. It's an estimate. It's my best guess for what the standard deviation is. I can now say, well, I'm going to build it off of this dude, which I'm assuming to be the real percentage. Okay, I like it. So step 4 in the hypothesis test is where we calculate Z star, right? So instead of using that formula on step 4, I'm going to use this one, because then I have places to put my percentages from the problem. I love it. How we doing? I'm still going to compare it to the Z I got on step 3 the same exact way. It's just I got to use this formula instead of that formula, because I got percentages. And now some of you guys are remembering when I said the Z-score formula never changes, and you're going, Jeff, your meds, you should probably take them. No. It's our data, minus the assumed middle, divided by the spread, divided by the spread. Always. It's always that. It's always that. It's just those things change depending on what situation I'm in, but the idea doesn't change. Okay. The second thing that's going to change a little bit is how do I tell if this kind of problem is normally distributed if I don't just say this? How do I tell it is? Yeah, n has to be greater than 30. But now for an NPQ problem, who remembers what I have to check to see if it's normal enough? Yes, there you go. So now for this kind of problem, NP has to be greater than, this book says equal to, we'll see, 5. Why says greater than? Different books change. NQ has also got to be greater than equal to 5. Oh, you guys semi-remember that? It had to do with the fact if NP is too small, it's slammed up against the wall, it didn't have room to go up and come back down. That was the point I was trying to make with that histogram I gave you guys in that handout from a while back. I like it. Oh shit. So n being greater than 30 is not good enough now. These have to be true. I like it. I like it. So let's just jump right in and try a freaking problem. Because all the steps are the same. Those two. How do we test if it's normal? This. How do I calculate z star? This. That's the only difference. The 5 steps are really still the same idea. So let me give you this. We're actually going to do, we're going to do it live. I made a little change. We're going to do number 2 together, and then I'm going to make you guys do number 1 by yourselves. We're going to do the side that's got number 2 on it.
Sure, I understand.
Shut up.
Do you really understand?
I just want you to do that in the middle of my lecture. You need one more? Are you with me? Sure, I understand.
Can't help showing up for that.
Oh, pass that back. I'm sorry.
Oh my goodness.
It's just super fun.
I know, we're in iPhones.
For me to put alarms to make sure it
That happened my first time. An alarm went off. Name alarm.
Alright, so read through that number 2. It's the one about college stats professors and the 4-week stats course during intersession.
Are we doing number 2, please?
What's up? Yes, there is. I taught one this past intersession. I taught it when it was 3 weeks.
Oh,
Back then, the intersession has not always been 4 weeks.
You're insane.
I'm not saying the people took the course. I know freaking stats. I didn't have
Like
any
quiz
problem.
today, tomorrow,
You
forever.
just cluster all the formulas together or something.
To be honest, they actually do better than my regular semester because they're not making anything else, and there's no time to forget anything. Of course, my question is really the heart of this thing: how much do they retain? right? They retain it for the same amount of time as somebody else, namely like 3 days. All right, so it should sound very familiar. Real quick, I think I just copy and pasted this stuff. Don't use 0.05 here. I want the 0.01 up there. You can see that? So put 0.01 down here for the level of significance. What is the claim that's being made?
It is the same as
So what do I write here?
Equals.
Good, P. You never use sample stuff or sample symbols. It's always a claim about the population. I'm not going to make a claim about a sample because I can see it. P equals,
84.5.
no, 0.845. I love you guys. It's the same thing, but just to remind you guys, you don't plug stuff into a formula unless it's a real number. Percentages are shit we made up. We want the decimal. So where does that go? Is everybody cool with that, by the way, just to start off? And of course, I was really nice. I bolded it. It's the same as. That's the claim that's being made. Which one does it go in for, the ho or the high? Just like, get a whole room full of people going, whoa. And then what's the high?
P not equal to.
P not equal to. So how many tailed tests will this be?
2.
2. I like it. So far, it feels very familiar. Just be careful. Don't use little mu's here. It's a test about a percentage. So use P. I like it. Now, the thing, I can't remember if I said this before. I think I did, because remember, there's only 3 formulas. There's X bar with Z and T, and then there's P hat with the Z. So either it's normal and you use Z-scores, or it ain't normal and you don't do shit. You never use T-scores with an NPQ problem. So can we use Z-scores? So we're going to have to check out. What do I check? No.
Add times P.
Yeah, the thing we just talked about a minute ago. NP. What's N?
322.
Yeah, the total number. I like it. 322. What's P?
0.845.
0.845. I love it. I didn't say P hat. I said P. And then I want 322 times Q hat. 155. It's pretty obvious they're both going to be bigger than 5, but you just got to show me. So what do you guys get for this first one here?
272.9.
Say that?
272.9.
272.9? 09? 09? 49? What do you guys get? 09. Thanks for your patience. I got you. And then what's this guy going to be? 49.91. I like it. And these are both?
Above 5.
Above 5.
Yeah. I'm used to doing this. Can't remember if the book does this or not, but I'm used to saying it's greater than 5. What does that mean?
Normal.
It's normal enough. I like it.
From what it says.
Normal enough for government work. All right. Now we know it's Z-scores we're allowed to use. We know it's a 2-tailed test. We know alpha is 0.01. What are those Z-scores going to be?
Two, 4, 5, 7, 6.
Yep. So you can use a T-score chart, of course, because at the very bottom of the T-score chart are Z-scores. So if you look at 0.01, 2-tailed test, that should be the first column, right? At the very bottom it says 2.5, so it's going to be 2.576 and negative 2.576. I like it. I hear some stuff about t-squared chi, z-squared to shit. But remember, t-scores become z-scores when the sample is large enough. Because t-scores exist just to make up for the fact that we only know s. But the larger the sample is, the closer s gets to sigma. So when the sample is freaking large, s is basically sigma. We don't need t-scores anymore, but they become z-scores. Whew. If you don't like all that, just use the z-score chart to find it. It's fine. The old-fashioned way, the longer way. All right, part D, summarize the sample information. Here's that formula we talked about a minute ago. So what's n? That's right, 322. What's x? The number of successes. 262, I like it. So what's p hat?
262 divided by.
And what's that going to be? Let me get my calculator so I don't have to suffer through the stuff from earlier. What do you guys get? And then I'll see.
0.81.
Almost.
0.814.
Yeah. Is that right? That's the same first step in like a confidence interval for a percentage problem, right? We're finding p hat. Do I need to figure out what q hat is? No, I don't need it. Anyway, you can if you want to, but I just don't need it. So z star is p hat 0.814 minus p. What's p?
0.845.
Yeah, good. 0.845. We're assuming this is the actual middle. 0.845 divided by the square root of 0.845 times 0.155 all over 322. And here's where you got to be careful. If you have the newer TIs, it's easier because your square root grows, so you know what's underneath it. If you have the older one that opens a parenthesis, just don't close it until the very end. Don't put any of these other parentheses in here. Open it, times, don't close it until you're done with everything that's under the square root. So let's see what you guys get, and then I'll show you how I did it in my calculator. Yes.
Are you multiplying 0.845 times 1?
Yeah, let me write it. So I wanted to write it the way you got to do it if you got the old calculator. The old calculator is going to do this: square root, parenthesis. So you got to go, okay, shit. I don't want to come out of the parenthesis. I don't want to come out of the square root until I get all this stuff there. So if you have the older calculator, the newer calculator, the square root button just grows. Whee! So you can see what's underneath. Are you guys with me? So the older calculator, got one right here. Is this an older calculator, Jeff? Yes. No, it's not. Shoot. Does anyone have the older calculator? Let me see real quick.
Pretty bad.
Huh?
It's pretty bad.
It's bad? Awesome. Square root, see, it opens a little parenthesis. You guys can almost see that. And then you have to do 0.814. Got it. So on the top you put 0.814 minus 0.845. That's the top. Put in parentheses so it knows it's on the top. You can almost see that. Divided by square root. Okay, you don't want to close that parenthesis until 0.845 times 0.155 divided by 322, and then you can close it if you want to. If you close it earlier, you're out of the square root. You're not doing the right formula. We both get the same thing. Oh, you tired? Yes. Thank you, gods. Okay. So we get a z star of negative 1.54. Now we can answer the question right now, and then I want to find the p-value. Negative 1.54, that falls like around here. So what does that mean?
We can support it.
Did we make it?
Yes.
No.
No.
We did not make it. All right, we're trying to get out of here. So we failed to. All right, what's happening? Let me go back up here because I didn't put this in words. Maybe this will help. If Z star is where?
Outside.
Less than.
Is outside. So is less than negative 2.576 or greater than 2.576, what can we do? That's the rejection region. It's really far away from the middle, and the HO is the one that thinks it's in the middle. So if we're way far away, we can then reject the null. Support the high. So the null is the one that's got the equal sign in it always, so it thinks it's in here somewhere. So if we get out into the rejection region, then it looks like that statement is wrong. We can reject that statement. We can support the other statement, because it's the opposite. It thinks it's outside. All right, so we got a negative 1.5 over. So can we reject the null? No, we failed to reject the null. So we fail to support the high. Those are the same statements. But I can't say the first guy looks like he's wrong. I also can't say the second guy looks like he's right. Same thing. Yeah, I get it. Now, there's one little twist to this for the p-value because it's a two-tailed test. But what's like the first step is the same. How do I find the p-value? How do I start to find it? What the hell is the p-value? Shit. Where's alpha on this picture? Where's alpha on that picture? Where's alpha?
The outside.
Yes, alpha is the shaded area. Alpha is an area. Right, which is one reason why they chose alpha for it. Yeah, Greek letter A. So that's the area out there. That's alpha, and that correlates to this z-score. Are you with me? Now notice the alpha was split in two. So if I only had one side, I'd have to double it to get alpha back. You guys are with me? Getting us ready for what we got to do. So if alpha is the area in the tail or tails of this critical z-score, the p-value is in the area of the tail or tails of my score, my z-score. So how much is below negative 1.54? What area is below negative 1.54? Point 0618? Yeah. Sounds like it could be true. So the p-value is not 0.0618. This is 0.0618. So based on what I just said earlier, what do you think the p-value actually is? I have to
Try. Find the difference.
I want to compare the p-value to alpha. What happened to poor little alpha dude? He got cut in half. I have to double it to get back to alpha. So this, I better double this to make it make sense to compare it. I love you guys. So if it's a two-tailed test, you just double that area. That's it, because it's a two-tailed test. I want to compare p-value to alpha. Now, to be honest, personally, I say we should compare that number to half alpha. Why the freak not? But oh well, I wasn't around, so the standard way of doing it is the p-value is officially twice this. Which kind of actually makes more sense because I want to know alpha by itself. What's alpha? P-value has to be at the same level. So I've got to double this to make it comparable. So what's the p-value then?
0.1236.
Okay. And 0.1236 is a hell of a lot more than 0.01. So you got the z-score that you can do and check to see and see what the answer is. You've also got the p-value. Again, just to reinforce this idea, I know we got the answer at the z-score, but in real life, we normally don't have an alpha given to us. We have our own internal alpha for a situation. So they report the p-value, and then we make up our own minds. That's a pretty big freaking p-value. I really want this to make sense. The p-value is related to the probability that our sample just happened randomly, that the mean is in the right place, or in this case, the percentage is in the right place, that we just happened to pick a sample that was however far away it was. So a 12% chance is not unusual. 12% chance. In fact, alpha was 0.01. We were saying it had to be less than 1% chance for it to be evidence that something was off. This is 12% chance. Shit, screw it, that could happen. Forget about it. It's not good enough to show evidence. That's why we failed. We failed to reject it because it was such a big probability of it happening by chance. If this was 0.001, that's like, well, that was freaky. If that is in the right place, the middle is in the right place, then our sample has a 0.001, a 0.1% chance of happening. Holy shit, the middle's probably not where they think it is. It's a much higher chance that that's just in the wrong place. So what was our claim? Which one? Which one was our claim? The hoe. The hoe was our claim? So then to write the conclusion, this is the part that really freaks people out, but there's no ambiguity here. Which one of these relates to the claim? This one, because the claim was the hoe. Right? So we'll use that language. Fail. We have not found. Sufficient evidence to reject the claim. You can make it the letter E. There you go. Reject the claim that what?
Proportion of passing students is different.
Percentage of professors who think it is amazing is 84.5%. Because the claim was is, right? The claim is it equals that. So we are not able to say it isn't the same. All right, so you guys try the other side. You can work together if you want to. You can shun others if you want to, either way. We have not found sufficient evidence to reject the claim that the percentage of professors who think it is amazing is 84.5%. So the important part of this, we have not found sufficient evidence to reject the claim that and you just copy
Oh,
what
yeah. Yeah.
the claim is. Yeah.
Good idea.
Kind of paraphrase it, but
I feel like this is the
The
claim.
claim is P is greater than 0.20, so the null would be P less than or
Greater than
equal. It's the opposite. Yeah, so it's greater.
20%.
So the null would be. It's
Oh,
less.
that seems right. All these 20%, 10%, greater than 50%.
there. There.
That's why I hate that. It's small. It's just super deep.
So the claim is greater than.
Yeah, I would get that.
P is greater than or equal to.
So, O is greater than.
Yeah.
I is less.
See, me and you would put this on the podcast.
It's like, yeah, it makes sense.
It's okay. It's like the first real day. So, any week when everything
Yep.
is
What do you mean?
So what's
Wouldn't it just be 420?
Oh, okay, sure.
with all of that?
You already got 420. Or no, never mind. I was going off this one.
Wouldn't it
Just
be?
because it was equal. So,
Yeah.
yeah, P would be greater than or equal to.
So P is 0.2.
That's
So
the.
ridiculous. Yeah, so P equal.
So it's
P is greater than.
39.6.
Well, whether or not are you squared? Good. What's the opposite of cutting in half? Doubling.